Nobody told you Jupiter was changing. Nobody put it in a headline. There was no flash in the sky, no alarm, no single night you could mark on a calendar. Just a slow, patient giant out in the dark, shifting the way it has been shifting for billions of years. But here's the part that should unsettle you. When Jupiter changes, Earth doesn't get a vote. And the last time Jupiter moved the way it's about to move again, the world your ancestors built everything inside began to freeze. There is a machine running at the edge of the solar system. It has no moving parts you can see. It makes no sound. It never announces what it is doing. It does not know you exist. And it has been in charge of something you were never told. It controlled the climate of this planet for longer than your species has been alive. The machine is made of gravity. Its gears are the orbits of the outer planets. And the most powerful hand inside it belongs to Jupiter. Most people have some general awareness that Earth's climate changes over long periods. Ice ages come and go, glaciers advance and retreat. That much gets taught in school and mostly forgotten by the following Tuesday. What almost nobody teaches, and what almost nobody knows, is the truth beneath it. The timing of those freezings and thawings is not random. It does not drift. It does not meander. It keeps a beat, cold, then warm, then cold again, with the regularity you would expect from a clock, not from a planet. Ice sheets, more than 3 kilometers thick, nearly 2 miles of solid ice, have buried the land your cities sit on today, melted completely away, and buried it again, dozens of times, in a rhythm. And that rhythm is not Earth's doing. Here is the question that should now be sitting in your mind like a splinter. If the timing of Earth's ice ages isn't random, and Earth can't create that rhythm itself, then what is keeping the beat? The answer is not on this planet. It never was. And the moment you understand what is actually controlling Earth's climate clock, and what it means that it's about to change the word terrifying in this title, will stop feeling like an exaggeration. For a long time, the evidence of ice ages was everywhere, but the explanation was nowhere. The scratched and gouged landscapes left behind by ancient glaciers were impossible to ignore. The rock record was undeniable. Something had frozen half the planet on a precise schedule, then warmed it back up, again and again, for millions of years. But the why was a wall nobody could see past. The answer came from a man working alone with a pencil. Milankovitch, a Serbian engineer and mathematician, spent years, including a stretch as a prisoner of war during the First World War, filling notebooks with one of the most painstaking calculations ever attempted by hand. While other prisoners wrote letters home, he computed, century by century, working out how the shape of Earth's orbit and the tilt of its axis slowly change over tens of thousands of years. No computer, no calculator, just arithmetic page after patient page, chasing the idea that ice ages were written not in volcanoes, not in the sun brightening or dimming, but in geometry. He was right. And here is the geometry, because you need to understand it before the terror of what Jupiter is about to do can properly land. 3 things about Earth's motion drift slowly on long cycles. First, the shape of Earth's orbit stretches and rounds. Sometimes our path around the Sun is nearly circular. Sometimes it pulls into a more elongated oval. This changes how much solar energy reaches us at different points in our year, cycling over roughly 100,000 years. Second, the tilt of Earth's axis nods up and down by a couple of degrees over about 41,000 years. Even small tilt changes dramatically shift how much sunlight the poles receive in summer. Third, the axis wobbles like a spinning top, slowly losing its footing, tracing a wide circle over about 23,000 years. This shifts which part of Earth's orbit lines up with which season. Stack those 3 rhythms on top of each other and you get the pattern that drives the ice. When they align the wrong way, the far north stops receiving enough summer sunlight to melt the previous winter's snow. The snow survives the summer. It piles up, year after year, Century after century, it becomes a glaciation.
So the ice is not really about temperature the way you'd think.
It is about geometry, about whether the northern summers are warm enough to undo the winters. And that geometry, that orbital shape, that axial tilt, that wobble, is not Earth's to control. Something else sets it. And this is where the giants step out of the dark. The shape of Earth's orbit is not Earth's doing. It is the gravity of other planets pulling on us across hundreds of millions of kilometers. And the heaviest hands on Earth's orbit belong to the two largest planets in the solar system, Jupiter and Saturn. Let me make Jupiter's size real, because the word giant gets thrown around until it stops meaning anything. Jupiter is more than twice as massive as every other planet in the solar system combined. Not just combined in pairs, all 7 other worlds, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, stacked on one side of a scale, Jupiter still wins, easily. More than 1,300 Earths could fit inside it. It accounts for roughly 75% of all planetary mass in the solar system. When something this heavy circles the Sun, its gravity doesn't politely stay in its lane. It reaches inward across the entire solar system. And it never stops pulling on us. Saturn, the second giant, is lighter, about 95 times Earth's mass, and much farther out. But far away does not mean harmless. Over tens of thousands of years, its steady, repeated pull adds up into something that can reshape an orbit entirely. Think of Earth's orbit as a loop of wire. Jupiter and Saturn are two hands slowly bending it, one pulling it more oval, the other easing it back toward round, over thousands of years. Neither hand is rushing. Neither hand ever lets go. Neither hand ever tires. The result? Earth's orbit constantly, gently breathes, stretching and rounding on a cycle, running about 100,000 years long. That 100,000-year stretch is one of the strongest single beats in the entire Ice Age record. The giants are not a footnote to Earth's climate. They are one of its authors. But there is something about Saturn that almost everyone misses, because on the surface it seems like it should matter far less than it does. Saturn is so light for its size that in theory, if you could find a bathtub large enough, the whole planet would float, less dense than water. And yet, that airy, almost weightless giant still has enough gravitational reach to help tilt the balance between ice and open ground on a world it will never come near. Here is the reason it punches so far above its weight. Jupiter and Saturn are locked in a gravitational conversation, where for roughly every 5 orbits Jupiter makes around the Sun, Saturn completes 2. Their closest approaches land in nearly the same places again and again, so their pulls don't cancel each other into noise. They reinforce. 2 giants, pushing in rhythm, can move things. Neither could move alone. It is the same reason a child on a swing goes higher when you push at exactly the right moment instead of randomly. The 2 objects quietly writing Earth's climate are a planet you could not float a boat on, and a planet that would float in a bathtub, working together across the emptiness with a patience no living thing could match. And the climate of your planet is the page they have been writing on since before your species existed. So when we say Jupiter is about to change, we are not talking about something abstract. We are talking about the author of Earth's ice ages shifting how it holds the pen. And what it's about to write, we've seen before. Before we talk about what Jupiter is about to do, we need to make Jupiter real. Not the textbook version. Not the pale dot you can find in a dark backyard sky. The real one. Jupiter has no surface you could ever stand on. Known. Drop toward it, and you fall first, through bands of pale ammonia clouds, those striped belts you can see through a backyard telescope on a clear night, then deeper, into a hydrogen atmosphere that grows thicker and hotter and heavier the further down you go, until the pressure becomes so crushing that the gas around you stops behaving like gas at all. Thousands of kilometers down, The hydrogen is squeezed so hard it becomes something that does not exist naturally anywhere on Earth. Liquid metallic hydrogen, an ocean of it, a sea of a substance that conducts electricity like metal, but flows like liquid, wrapping the planet's unknown core in something we have never touched and cannot yet reach. There is no line where atmosphere ends and ground begins. There is just more and worse and heavier all the way down. The pressure at depth climbs to millions of times what you feel at Earth's surface, enough to flatten any machine we have ever built long before it reached even the halfway point. We have never touched Jupiter's core. With the technology we have today, we never will. Everything we know about the inside of this planet, we have learned from the outside, from its gravity, from its magnetic field, from watching how it bends spacecraft that pass near it. Here is a fact about Jupiter worth keeping permanently. Jupiter gives off more heat than it receives from the Sunday. It is slowly leaking warmth left over from its own birth energy, stored 4.5 billion years ago when the planet first formed and squeezed itself together under its own crushing gravity. Jupiter is still very gently shrinking right now, contracting inward by a small amount every year. That slow collapse releases heat. Jupiter glows faintly with a memory of how it was made. It has been doing this for the entire age of the solar system. It still isn't finished. Hold that whole picture. A planet so vast, it bends the orbit of a world hundreds of millions of kilometers away, leaking the warmth of its own ancient birth, with its gravity quietly helping decide when ice swallows our continents, and most people will live and die without knowing a single piece of this was happening above them. There is one more detail about Jupiter that makes its slow gravitational work on Earth land even harder. Jupiter spins faster than any other planet in the solar system. A full day on Jupiter lasts under 10 hours. A ball more than 11 times wider than Earth, with a mass over 300 times greater, whirling so fast that one complete rotation takes less time than a single work shift. That speed is why Jupiter isn't a perfect sphere. It visibly bulges at its equator, squashed outward by its own spin, like something flung apart from the inside. The same planet does one of the fastest things in the solar system and one of the slowest simultaneously. The 10-hour spin you could watch through a backyard telescope in a single evening, and the gravitational grip on Earth's orbit that takes 100,000 years to complete one full swing. Violent and pascient, fast and geological, both at once. And it is always the patient side, the quiet, invisible, never-tiring side that moves walls of ice across continents. Now, let's talk about what is changing. For nearly 400 years, humans have been watching Jupiter's Great Red Spot. First documented in 1665 as the permanent spot, it has outlived every scientist who ever pointed a telescope at it. It is a storm system wider than the entire Earth, its top cloud layers towering more than 5 miles above the surrounding cloud deck. At the edges, winds tear along at up to 420 miles per hour, faster than any storm Earth has ever produced. It is one of the most enduring features in the solar system, and it is changing. Since the early 2000s, the Great Red Spot has been measurably shrinking. In 2019, it began flaking at the edges, small pieces breaking off and dissolving into the surrounding atmosphere. In events researchers called flaking and peeling. Scientists who have tracked it for decades now project that if the current process continues, the Great Red Spot may, within coming decades, become a far smaller, more circular feature, or change character entirely. A 400-year-old storm that has outlived everyone who ever watched it, slowly coming apart. But here is the thing that makes this more than a weather headline. The Great Red Spot is not just a storm. It is a symptom. It is one visible expression of the forces driving Jupiter's internal dynamics, the deep convective currents inside the planet, the interaction between its powerful magnetic field and its ocean of liquid metallic hydrogen, and the oscillating internal wave patterns that NASA's Juno spacecraft has now directly measured pulsing through the planet's interior. When Jupiter's internal dynamics shift, when the deep magnetic and convective patterns change their rhythm, the outside changes, the cloud belts shift, the storm structures evolve, and the gravitational signature that Jupiter broadcasts outward across the solar system changes with it. Not dramatically, not overnight, not in any way you could film and post as a breaking story, but measurably. And to the orbital mechanics of Earth, measurably is everything. Because what Jupiter is about to do is not a story about a storm shrinking. It is about the orbital configuration, the specific gravitational relationship between Jupiter, Saturn, and Earth, approaching a position it has not occupied for a very long time. How long? Before we answer how long, we need to establish that any of this is real, because a claim this large needs more than a dramatic title. The proof of Jupiter's grip on Earth's climate stands on two legs. The first is the mathematics. Scientists build precise models of the entire solar system, every major body, every gravitational interaction between them, and run those models forward and backward across millions of years, tracing orbits step by step. They do not put the rhythms in by hand. The long cycles emerge on their own, from nothing but gravity. Earth's orbital shape rises and falls in waves, with periods near 100,000 and 400,000 years. Those numbers fall directly out of the pull of Jupiter and Saturn. The giant's influence isn't assumed or inserted. It appears every single time the simulation runs, from any starting point. The second leg is the Earth itself. Drill down into ancient layers of seabed sediment and polar ice that accumulated over millions of years, and you find the climate cycles preserved like rings in a tree. Bands of warm and cold, wet and dry, stacked one on top of another in patterns that repeat with mathematical precision. When scientists measure the spacing of those layers, the orbital rhythms are right there. The same 100,000-year beat, the same 41,000-year tilt cycle, the same 23,000-year wobble in the stone, in the ice, written down by the very climate the giants helped shape long before anyone was alive to read it. The turning point came in 1976, when scientists Hayes, Imbrie, and Shackleton published a landmark analysis of deep-sea sediment cores stretching back nearly 500,000 years. The climate rhythms buried in the seabed matched the exact periods Milankovitch's calculations predicted. The orbital tilt cycle, near 41,000 years, the wobble, near 23,000, the orbital stretch near 100,000. Their paper carried a title that said the quiet part out loud. They called these orbital cycles the pacemaker of the ice ages. A man with a pencil, working alone in a prisoner of war camp, had heard the heartbeat of the ice decades before anyone could confirm he was right. And the Earth had been keeping that exact beat the whole time. We did not invent these cycles. We dug them up. They were waiting in ice cores pulled from under Antarctica, in layered cliffs of ancient seabed, in the geology of a planet that has been keeping records far longer than we have been asking questions. The rocks remember Jupiter and Saturn, even though no single human ever could. And the record they keep tells us something very specific about the moment we are in right now. Something the rocks have only shown us once before in living memory, and what happened that time should give you pause. Before we reach what Jupiter is about to do, let's make the stakes physical. Because Ice Age is an abstraction until you stand inside one. Around 20,000 years ago, the last time the glaciation was at its deepest, if you lived anywhere in the northern half of the world, the ground beneath your feet was buried under a wall of ice, taller than the highest skyscraper in your city. Not a glacier you would hike to. A frozen ceiling pressing down on the land where your home is. In some places more than 3 kilometers thick. Nearly 2 miles of solid ice, grinding slowly southward, scraping the landscape flat as it moved. The air was bone dry and brutally cold. The sea had pulled back so far that beaches you walk today would have sat far inland. The shoreline had retreated over the horizon. Whole forests were gone, replaced by frozen plains stretching in every direction. Sea levels dropped by more than 100 meters over 300 feet, enough to expose land bridges that early humans walked across to reach new continents. The map of the world your school showed you those coastlines, those islands, those places where the first cities eventually grew, was shaped in part by a rhythm set in the outer solar system, and none of it was triggered by anything on Earth. The thing that decided your patch of the planet would freeze was the angle of sunlight in the far north, set by a wobble and a stretch in Earth's orbit, nudged by two planets you could not see in the daytime sky. That is what Jupiter is changing actually means when you follow it to its end. It is not an abstraction. It is a wall of ice where your street is. Over the last few million years, Earth has swung in and out of glaciation dozens of times. The ice has come and gone again and again, like a tide measured in tens of thousands of years instead of hours. Each time the orbital geometry shifted wrong, the ice came. Each time it shifted back, the ice retreated. The seas rose, the land bridges drowned, and the warm window opened again. And every single swing was written in advance in the geometry of orbits by the patience of the giants. Here is what is changing. Jupiter's orbital configuration, the specific gravitational relationship between Jupiter, Saturn, and the inner solar system, moves through patterns on multiple timescales simultaneously. The grand 100,000-year orbital eccentricity cycle is the one most visible in the Ice Age record. But nested inside that grand cycle are shorter period configurations, specific alignments of Jupiter's orbital parameters with Saturn's resonance pattern that create their own distinct gravitational fingerprints on Earth's orbit. Some fingerprints nudge Earth's orbital eccentricity in ways that intensify seasonal contrasts in the far north. Others moderate them. Some combinations allow northern summers to stay just warm enough to melt the previous winter's snow. Others tip the balance the wrong way. The specific configuration that Jupiter is approaching right now, the orbital relationship between Jupiter and Saturn, phased against the current positions of the Milankovitch cycles, is one the solar system has visited before. The last time this configuration occurred, the warm interval that had been running before it was in its final phase. The orbital geometry had rotated into a position where northern summers were beginning to lose the fight against northern winters. Snow that had been melting every summer began surviving the first year, then the second, then a decade, then a century. The ice sheets at high latitudes began to grow slowly at first. Then, with the unstoppable momentum of a feedback loop, white ice reflects sunlight back into space instead of absorbing it. The more ice grows, the more sunlight gets reflected. The cooler things become, the more ice grows. The previous warm window was closing, and the thing that closed it was not a volcano, not a meteor, not a sudden change in the Sunday. It was geometry. Jupiter and Saturn shifting the way they always shift, rotating the orbital dial toward the configuration that reduced northern summer warmth enough for snow to survive. Now the dial is rotating back toward that same position. Not overnight, not this decade, not in your lifetime, not in your great-grandchildren's lifetime, but on the timescale that Jupiter operates, on the timescale on which ice ages rise and fall, we are moving back toward the orbital address where the last warm interval ended. The machine is turning. The giants are doing something quieter and far heavier than anything you could film or post as a headline. They are keeping time. And the clock is approaching an hour it has shown before. The last time it showed that hour, the warm window closed. Before this lands as something it is not, let's be precise. The orbital cycles are slow. Tens of thousands of years for the rhythm to complete one full swing. This is not an announcement, that an ice age is dropping on your grandchildren. The geometry moves on a timescale that makes all of recorded human history, every empire, every war, every invention, look like a single afternoon in the life of the machine. And there is a faster, closer force acting on Earth's climate right now that operates on a completely different clock. The carbon we are adding to the atmosphere works on a timescale of decades, not millennia. The giant's clock is slow. What we are doing to the atmosphere is fast. Both are real. They just run at different speeds. But here is the thing that makes the orbital shift unsettling in a way that has nothing to do with timeline. This machine does not know we exist. It was turning long before there was anything alive to feel it. It will keep turning long after the last trace of us is gone. The warmth that built our entire world, every city, every crop, every idea your ancestors ever had, was an arrangement of gravity we had no vote in and no power over. We are tenants in a house whose foundations shift on a schedule we can barely perceive, paying rent in time we did not know we owe. The warm interval we live, in the stable, calm window inside which all of human civilization was built, was not guaranteed. It was handed to us by timing, by the position of the orbital wheel at the moment our ancestors happened to stop running and start building. We came out of the last ice age into a warm, steady period and built everything inside it: farming, cities, writing, philosophy, science, medicine, music, every empire that ever rose, every invention, from the wheel to the rocket. All of it fits inside one warm interval between glaciations. And the length and warmth of that interval is shaped in part by where Jupiter and Saturn have nudged our orbit. The giants set the room temperature. We just walked in, got comfortable, and built a civilization with no idea who was holding the thermostat. There is one more layer, and it is the one that makes Jupiter feel less like a planet and more like a slow, immense force you should genuinely respect. Not fear, but respect the way you respect something that does not notice you, but is capable of reshaping everything you stand on. Jupiter's grip does not stop at gently breathing Earth's orbit in and out of shape over 100,000-year cycles. Over deep time, billions of years, the gravitational tug-of-war between Jupiter and the inner planets can build up in ways that turn dangerous. Run the solar system forward far enough in the same orbital simulations that gave us the Milankovitch Cycles. Run them out billions of years, and the orbits stop being perfectly predictable. Tiny nudges accumulate. Then they feed on themselves. In some long-range models, Mercury, the smallest planet, closest to the Sun, has its orbit stretched by a slow resonance with Jupiter until, in a small fraction of simulated futures, it destabilizes entirely, flung onto a path that could end in a collision with Venus, with the Sun itself, or thrown into the inner solar system in a way that eventually threatens Earth. Let me be careful here, because this is exactly the kind of fact that gets torn out of context and used irresponsibly. The odds are low, around 1% over the next 5 billion years, a timeline that extends past the point where the Sun itself begins to die. This is not a warning about anyone's lifetime, but it tells you exactly what kind of object Jupiter is. It is not a neighbor. It is a slow, colossal engine of gravity that has been quietly steering the fates of the other planets since before Earth had oceans, and it will keep steering them long after the Sun begins to fail. Its hand on our ice ages is only the part of that power gentle enough to let us survive underneath it, and its moons tell you the rest of the story. Io, one of Jupiter's 4 large Galilean moons, should be a dead, frozen rock by any normal planetary logic. Instead, Jupiter's gravity kneads it relentlessly, squeezing and releasing it on every orbit. The friction keeps Io's interior permanently molten. It has more than 400 volcanoes. Around 150 of them are erupting at any given moment. Some shoot sulfur plumes 200 miles into space. Jupiter tortures its own moon into staying alive. Even its family doesn't get to rest. Violent to everything in its immediate reach. Patient and indifferent to everything farther away, including us. To understand Jupiter, to confirm that what Milankovitch calculated from a prison camp was actually real, we had to go there. And going there is its own quiet story of machines thrown across hundreds of millions of kilometers to a planet that does not want visitors. Pioneer 10 arrived in 1973, the first spacecraft to reach the outer solar system. It flew straight through Jupiter's radiation belts, an invisible storm of charged particles trapped by the planet's magnetic field, so intense it threatened to destroy the spacecraft's electronics. Nobody was entirely sure it would survive. It did just long enough to send back the first close-up photographs before the radiation degraded its systems. Jupiter's magnetic field, by the way, is the largest single structure in the solar system after the Sun's own reach. If your eyes could see it from Earth, it would appear larger in the sky than the full moon. A vast, invisible bubble with entire moons orbiting inside it. The two Voyagers arrived in 1979. They caught Jupiter in motion, filmed the storm bands flowing in real time, watched the Great Red Spot churn, and discovered something nobody had predicted. Io, that small inner moon, covered in active volcanoes spraying sulfur directly into space. A world that should have been a dead, frozen rock, kept alive by Jupiter's gravity kneading its interior. Nobody had expected it. It broke everything the models had assumed about small moons. Galileo committed in 1995 not a flyby, an orbiter. It spent years circling Jupiter, mapping the planet and its moons in unprecedented detail. On the way in, it dropped a probe straight into the atmosphere. That probe plunged in behind a heat shield that flared to thousands of degrees, then opened a parachute and drifted down through the clouds for 58 minutes, radioing back the first direct measurements ever taken from inside a giant planet. Temperature, pressure, chemistry, all of it. Until the heat and pressure finally overwhelmed the transmitter. Within hours, the probe was gone. Melted and vaporized somewhere in the deep atmosphere. It didn't crash. It simply stopped existing, swallowed by the planet it came to study. And today, Juno loops over Jupiter's poles on a continuous orbit. Its electronics sealed inside a titanium radiation vault, peering deeper into the planet than anything before it. Juno revealed that Jupiter's core is not the neat, solid sphere we expected, but something stranger. A fuzzy, smeared-out center that blurs into the layers above it. A planet with no clear boundary between inside and outside. A planet that refuses to be defined cleanly, even when we are looking directly at it. Every one of these machines was a gamble, thrown across hundreds of millions of kilometers to a place that does not welcome visitors. And everyone came back with the same message. Jupiter is bigger, stranger, and more powerful than the textbook ever let on. Pull all the way back. Here is everything we actually uncovered. Earth's climate keeps a measurable beat, a documented rhythm of ice ages and warm periods cycling over tens of thousands of years, preserved in ice cores, seabed sediments, and glacial landscapes, carved by a machine that has been running since before life crawled onto land. That rhythm has authors the three Milankovitch cycles of orbital shape, axial tilt, and polar wobble, all driven in part by the gravitational influence of Jupiter and Saturn, whose 5:2 orbital resonance creates the 100,000-year beat that dominates the Ice Age record. The proof was written into the Earth long before we looked confirmed in ice cores drilled from under Antarctica, in deep-sea sediment cores stretching back 500,000 years, where the orbital rhythms appear exactly as Milankovitch predicted. The pacemaker of the Ice Ages. Written in rock and ice. Waiting. Jupiter is changing its great red spot shrinking, its internal dynamics shifting as Juno measures deep oscillations inside the planet. and its orbital configuration rotating back toward the alignment it held when the previous warm interval ended. This is not a warning for tomorrow. The orbital cycle operates on timescales of tens of thousands of years. Human-caused climate change operates on decades. Both forces are real. They run at completely different speeds. The giant's clock is slow, the atmosphere is fast. The warm window we live in was never guaranteed. Every city, every crop, every idea your ancestors ever had was built inside one warm interval between glaciations. The giants set the room temperature. We just walked in. Jupiter's full power is something else entirely. Its hand on our ice ages is its gentle side. Over billions of years, it can destabilize Mercury, reshape the inner solar system, and torture its own moons into volcanic life. The gentle version is what allowed us to exist. There is a way to feel the distance one last time that never fails to put things in place. Light moves at 300,000 kilometers per second, the fastest thing there is. And even at that impossible speed, sunlight takes more than 40 minutes to reach Jupiter, sitting out there on average around 778 million kilometers from the Sunday. And yet across all of that emptiness, across all that dark, Jupiter's gravity still reaches inward, all the way to us, and helps decide whether the north freezes. Gravity does not fade with distance the way our instincts insist it should. It crosses the dark patiently, and it never lets go. We are incredibly small. We live inside the slow breath of planets that have no idea we are here. That would not notice if we vanished. That will go on shaping Earth's orbit for billions of years after the last of us is gone. But we figured out the rhythm anyway. We pulled it out of simulations and ice cores and layered cliffs of ancient seabed. We understood for the first time in the history of life on this planet just how much of our warm, fragile, improbable story has always depended on giants we will never touch. That is the part worth carrying with you tonight, after the screen goes dark. Not fear, not doom, just the strange, quiet weight of knowing that the stable sky that let your ancestors stop running and start building was handed to you by the slow turning of orbits shaped by worlds you will never see. And that you were lucky enough to be born in the warm, open window before the ice comes back. Jupiter has been keeping time since long before we had a word for it. Tonight, just for a moment, we got to watch what it's about to do next. Thanks for watching. See you in the next one.